Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Mastering Data Structure and Algorithms in Java. Today's data structure is queues part 4. So we have already covered queue data structure. What a queue data structure is, please go through part 1, 2 and 3 and especially go through part 1 if you want to understand queue data structure. In this one we are going to go particularly in ArrayDeque. So we learned that in queue data structure, queue is a linear data structure that follows first in first out, unlike stack which follows last in first out. We majorly have two operations, enqueue, dequeue. Type of queues, we have simple queue, circular queue, priority queue as covered in last video, and double-ended queue or Deque. Right? Where does queue lies in the Java interfaces? Java collection is queue extends collection, which extends iterable, and it is implemented by three classes. So there is linked list class, priority queue class, and ArrayDeque class. In part 2 we saw how to implement a custom linked list queue. In part 3 we saw how to implement a custom priority queue, and in this one we are going to see how to make a custom ArrayDeque queue. Okay, so queue interface is implemented by, as we saw, linked list, priority queue, and ArrayDeque. Linked list and priority queues we have covered. I'll just quickly remind you that linked list queue is the most basic queue, where you have a queue, you enter the elements from one side, you remove the elements from other end. This would be the simplest queue or linked list queue. Second is priority queue. So in priority queue, so for a linked list queue, let's say, or generic queue, if you enter the number in the order 1 first, then second, then third, the output is going to be 1, then second, then third. For priority queue, or if you add like 4 2 1, you'll get the output as 4 2 1. For priority queue, it is the priority that matters, and for the numbers it's generally the lowest number with the highest priority. So for 1 2 3, output is going to be 1 2 3. For 4 2 1, output is going to be 1 2 4. Okay, so priority queue implements heap, min heap in the backend. So please go through the third part of the queue series or the previous video to understand priority queue. Really important concept. Okay, in this one we are going to cover ArrayDeque queue, right? So this is the whole difference. Let's say this is a queue, okay, and we enter from one end, we exit from the other end. That is the basic queue nature. But for ArrayDeque, what happens is it's double-ended queue. So you can insert from this end, out can be from this end. At the same time, you can insert from this end, and the out can be from this end as well. So we have offerFirst, offerLast, pollFirst, pollLast. Okay, so to whether to add the element at the end of the queue, or to fetch the element from the end of the queue, or to add the element at the start of the queue, or fetch the element at the start of the queue. All these operations can be done for ArrayDeque queue. Okay, let me delete this. Okay, now there are few things that we will be seeing for ArrayDeque. Okay, let's go back. So ArrayDeque is suitable for use cases where we want to implement both stack and queue functionalities. It provides better memory efficiency, and you can do the operations from both ends, right? The other parts this we will come to. So let's understand. In this video we are going to cover what is ArrayDeque. We are then going to implement custom ArrayDeque, and then we are going to go through the output. So how we generate the output and how it is actually calculated. Okay, so let's start with the ArrayDeque first. Okay, so ArrayDeque queue. So first thing is, it uses an array as its data structure, underlying data structure. So we may have a fixed size for this data structure. Then you need two things. One is you want to insert from this end, so you can call it, let's say, offerLast, and from this end we'll call it offerFirst. Okay. Similarly, if you want to remove an element from this end, we'll say pollLast. And if you want to add an element or remove an element from the front end, we'll say not this, we'll say pollFirst. Okay, simple. So let's say you have 1, 2, 3, 4. You can add them in any order. So you added 1 first, so 1 will be added in the first. Then you add 2 first, 2 will be added in the from the first end on this. You add 3 end. Let's say for 1 first you added here, 2 got added here, 3 will add here from the offerLast, and 4 from offerLast will be here. But then you should remember that the offerLast last position is this one now, and from front the last position is this one now. So and since this is an array, we need to keep separate pointers. So we'll keep 2 pointers for head and tail. If the head crosses this size, we'll circle back from the start. Same way, if the tail crosses any of the side, we'll circle back from the opposite end. Also, if head and tail meets at the same end, we know that the complete array has been utilized, and we will resize it. So what will happen? We'll increase the capacity of it. Let's say the initial capacity was 4. We'll define a new custom capacity. Maybe we double it directly, and we'll get the new capacity as 8. Okay. So let's implement a custom ArrayDeque. In part 1, we have already seen how we can use a ArrayDeque queue, right? How we can use a ArrayDeque, but in this one we are going to see how we can implement our own custom ArrayDeque queue. Okay, so let's get started. I've created a class for ArrayDeque. Excuse me. Okay, let's run. At 10:45 engineering, it's working. Okay, so we need our own custom ArrayDeque, so we are calling it ArrayDeque queue. Okay, let's see what all do we need. First, we need to have a initial capacity, so we'll say private static final int initial capacity. So this will be the initial capacity which we are hard coding to 16. Okay, that's why we made it final. Now we'll create an array of elements. Now if you remember from our priority queue, we made it generic, right? Similarly, for the linked list queue, we made it generic. So we'll do the same for ArrayDeque queue as well, so that we now develop a ArrayDeque queue custom class that is valid for integers, floats, characters, strings, or objects. Okay, so we'll go with the objects. Private, we'll create an array of objects, object, and let's call it elements. Okay, what else we need? Yeah, we need 2 variables or pointers, so let's call private int head initially 0, private int tail initially 0. Okay, now when we talk about ArrayDeque, we need a few of the methods like offerFirst, offerLast, pollFirst, pollLast. Before that, we also need a constructor for our code. So we'll say public ArrayDeque queue. This will initialize the initial elements. Elements is equal to new object, and we'll have the initial capacity. So now once the class is initialized, a new array of elements is created, array of objects is created with the initial capacity of 16. Okay, now what all do we need? We need offerFirst, offerLast, pollFirst, pollLast, right? So we'll add element to the front, or okay, let's make it this way, front or head of the queue, not queue, Deque, because it is double-ended queue. So, or Deque, right? So we'll say public void offer first. What do we need? We need data, so it can be t value. Now okay, I will explain you how this works first. So first we will check if the head has reached the same size as the tail, and do we need to resize, right? So we'll check if head, or we'll need one more, if head minus 1 plus elements dot length mod elements dot length. Why we are doing mod? Because once the array boundaries are over, as we saw here, once the array boundaries are over, let's say the head was already here and we want to increment the head, rather than going array access out of bounds, it will return to next address value. Okay, so let's go back. Okay, so if head minus 1 plus elements dot length mod elements dot length is equal to tail, that means we need to resize it. So how will we resize? We'll create another function. Okay, we'll create another function, we'll call it resize. Okay, otherwise first we will increment head. So head is equal to head minus 1 plus elements dot length mod elements dot length. Okay, so we'll increase the size of head, increase the value of head. So for the earlier case, when the head is at 0, let's say for the very initial case, we have this array. So array starts the indexes from 0, 1, 2 and like this. We have our 2 pointers. We'll have head pointing to 0, tail pointing to 0, right? Now what are we saying in our formula? We are saying head is equal to head minus 1 plus elements dot length and then mod of elements. Okay, let's say the array size was this, for simplicity, 4. So size is 4, head was 0, so we'll do 0 minus 4 mod 4. Side, that is correct or wrong? Let's go. We have written head minus 1 plus elements dot length. Almost missed. Head, so 0 minus 1 plus elements dot length mod 4, right? So 0 minus 1 and plus 4 is 3, mod 4 is equal to 3 again. So 0, 1, 2, 3. This is where the head will be pointing now. So if I if I do offer first, so as you see we are implementing offer first, it will enter the value at the front of this Deque. So a new value will get added here, value, and then next time again we add, we'll follow the same formula. If you want to insert from head, we'll do head current value, that is 3 minus 1 plus 4 mod 4. So that will be 3 minus 1 2 plus 4 6 mod 4 is equal to 2. So next time the index would be here and next value will come at the next index. So if we insert from front, value is inserted here then here. If we insert from back, offer last, it will add it here then here. Similarly when we remove, it will be in the reverse manner. Okay, now let's go through the implementation first and then come back to the how we are actually calculating the values. So we'll say head is equal to head minus 1. We increase the value of head. Now we should enter the element as well. Our array name is elements, so elements at index head will get the new value. Okay, now next is what do we want? We want offer first, offer last. So we'll say add element to the end or tail of the Deque, double-ended queue. So we'll say public void offerLast, not 0, we'll pass t value. Now similarly, how we calculated the value for head, we'll calculate the value for tail, but again we would have to do a resize check. So we'll check if tail plus 1 mod elements dot length is equal to head. If it's so, then means we need to resize. Okay. Otherwise, first we will add the value to elements. So just to understand that initially head was at 0, tail was at 0. So tail of 0 already points to this end, right? So we will add the element first and then change the value of tail to point to next one, right? So let's go. Okay, we'll say elements at tail is equal to value, and then increase the value of tail. So tail is equal to let's take it in bracket, tail plus 1. So this is all that the value has to be increased, but since now we'll do the circular that it should reshape again. So if it crosses the value, it should again start from 0. We'll do mod of, leave some gap, mod of elements dot length. Okay, why elements dot length and not 16 directly? Because again the length could be increasing, right? Okay, so we added offerFirst, offerLast. Now we need pollFirst, pollLast. Okay, so for this we'll say remove and return the element at the front, that is head of the Deque. So we'll say public t pollFirst. Now since we are removing, we don't have to check for resizing, but we have to check what if the list is already empty. So we need a isEmpty method as well. We'll create that as well. If is empty, okay, then we'll throw the new exception, or we could just return null. We can say return null. Okay. Otherwise t value is equal to elements of head. First we fetch the value. What is the issue? Okay, we'll typecast it. Okay, so we have just typecasted back from the elements to the t type, so that if integers were added in the array, it will be returned in the form of integers. If strings were added, it will be returned in form of strings. Okay, so we fetch the value to, and then we should change the head as well, or we have to remove the value as well. So we'll say elements at head is equal to null. So we got the value, we made the value null. We'll update the head. Head is equal to head plus 1. Why plus? Because now we are removing. Earlier we were doing minus. Head plus 1, again same, mod of elements dot length, and lastly return value. Okay. Okay, now similarly pollFirst is done. We need pollLast as well. So we'll say remove and return element at the end, that is tail of the Deque or double-ended queue. So we'll use the same methodology, public t pollFirst now, right? Now again we'll only check for if the list is empty. So if is empty, we'll say return null. Otherwise, first we will update the tail and then we will return the value. For addition, we were first adding the value and then updating, and the same was reversed for pollFirst and pollLast. Okay. So now we have to first change the value. So tail will become tail -1 because we were doing +1 while adding. Tail -1 plus elements dot length mod elements dot length. Okay, and then t value is equal to elements or tail index, and finally element at tail index is equal to null. Okay, again we have to typecast it. Okay, that is done, and in the end we will return what's the spelling, return return value. Okay, now pollFirst, pollLast is done, offerFirst, offerLast is done, peek is pending, which is a very important method in queues, which returns the value but does not remove it from the queue. So we'll do peek at the element at the front, will only peek from one end. You can actually implement from the back side also, it doesn't it's not that different. Okay, so we'll say public t peek first, and we'll say return if it's not empty is empty, no, we'll check. If it is empty, we'll return null, otherwise elements at head. Right, we don't have to make any changes to head or remove the element because we are not removing the element, we are only peeking the element. Okay, I'll typecast it. What is the issue? Public t, what is it saying? Invalid method declaration, return type required. Return type is there. Okay, public t. Okay, similarly okay, let's implement from the front as well. It's not much change. Peek at the element at the end, that is tail of the deck. So we'll simply say public t peek last, return, same logic, return is empty, yes, then null. Otherwise, now we want to return it from the last, so we have to calculate the value while peeking the element. So since this is what we did for removal as well, for the last part, not for the first part, offerFirst of remove first, but for the pollLast. So if we go for pollFirst, we want to see this, we want to check for tail, pollFirst tail. So tail's value is changed first and then return the value. For header, it's the value is returned first and then the value is changed, but since we do not move the header, it does not matter. But in case of tail, we have to return, we need to go to previous value and then return the value. We'll not be removing it, but we need to peek the element. So we'll say null, otherwise let's typecast it already, t elements of, we need tail -1, yes, we need tail -1, so we'll say tail -1 plus elements dot length, then mod elements dot length. This will fetch us the exact value. Okay, so if it is not if it is empty, will return null. If it is not empty, will return the last tail value. So will return peak, will be peaking from the last. Okay. Now let's quickly implement our resize. What should we call the resize the backing array? So the underlying array which is being used when it is full. So every time when people are calling resize, we'll be calling to this method, private void resize, and we'll say new capacity is equal to previous capacity, that is elements dot length multiplied by 2. Okay, and then we'll create another object, array object new array is equal to new object with the new length, that is new capacity. What else? Int size is equal to, we need the size method also, size. We'll create a method for this so that we can do for loop for int I equal to 0. We need to copy all the elements that were existing in the previous array, right? I less than size I plus plus. So we'll say new array of I is equal to elements head plus I. So head is already at 0, so head plus I, and then since we want to curve it, mod of elements dot length. Okay. What else we would need? Then we have added the values, element new array of I is equal to elements of head plus I, so we added all the values from the head. We also need to change elements, will now be new array, and head again will go to 0. Tail will be tail cannot go to 0 because now all the elements that have been added have to be recorded, so tail will be at the end of the size. Okay. What else is pending? Okay, our size method is pending, of course. So return the number of elements in the Deque. Okay, so when we are copying all the elements from elements to new array, from elements array to new array, we only copied the values that are available, right? So we'll calculate the size, public int, because if we are inserting, so let me quickly explain this part. Let's say the initial capacity was really big. Okay, let's say the initial capacity was really big, the array was something like this, and we have been adding poll head from this end. So 1 was added, 2 was added, 3 was added, 4 was added, and from rear end using offerLast we added from this end. 10 was added, 18 was added, 7 was added, 6 was added. So this area is blank, right? When we are creating another big array bigger than this one, we want to copy the previous elements into this new array. So we can directly copy it from head is already pointing here, tail is pointing here. We can actually take this complete length, which gives out the size. So this is the logic that we are using to implement size, that we'll be using in the size method. So public int size, let's return return. So how will we calculate tail minus tail minus head plus elements dot length, and then we'll do the mod. So mod, not space mod, elements dot length, right? Do we have, oops, elements dot length. Okay, do we have any other method? I think our is empty is not implemented, is empty is needed. Okay, check if the Deque is empty. So now that we have the size method, we can directly check it. So public boolean is empty. We'll say return if head is equal to tail, because when head and tail reaches the same position, it is empty. Okay, we'll come to our main method. Okay, we have everything. So now what all do we need? We'll create a object for our custom class that we have created, ArrayDeque, and then start printing the elements or start performing the operations. So let's do that. The name is ArrayDeque of type integer. Since we have built it with generics, we can use anything. Deque or DEQUE, Deque is equal to new ArrayDeque. Okay, now we'll adding the elements. So we'll say Deque dot offerFirst 10, let's say. Again Deque dot let's enter from last, offerLast 20. Okay, then we need Deque dot offerFirst 5, and then last one Deque dot offerLast, that is 30. Okay, now once this is done, we'll try to access them from both ends, we'll try to remove them from both ends, and we'll finally try to peek them from both ends or check the remaining elements from both ends. So we'll say access elements from front and from both ends. So we can say system dot out dot println first element, that will be, what will we use, Deque dot peek first, right? Similarly, I'll use the same line. What do we need? Last element. How can we get it? Deque dot peek last. Okay, now similarly we'll have remove elements from both ends. How do we remove elements? So first we'll remove from the front, so we'll say removed from first Deque dot pollFirst. Why is it showing error? ambiguous method ArrayDeque and ArrayDeque match pollFirst. Our method name is pollFirst only, right? Where is pollFirst? pollFirst, what's the issue? Already defined in ArrayDeque. pollFirst was already defined. pollFirst is there. Now what did we miss? So we built offerLast. Why these elements are built twice? At the front, offerFirst, offerLast. Remove and return the element from the front. So pollFirst and pollLast. So we mistyped it. Last, let's check the logic. So for first, we first get the value, change the head. For last, we first change the tail, then get the value. Okay, so pollFirst, and we'll use the same method, same, remove from last, that will be Deque dot pollLast. Okay, what else? Will check for remaining elements. Okay, so we'll say not removed. What can we check? Remaining first element. Okay, so which is the first element now after removing it? So Deque dot peek first, right? And similarly we'll lastly check for size of Deque, whatever is left. So Deque dot size. Okay, now before I run this and generate the output, please take a minute and try to guess what is going to be the output. Okay, I'll begin now. Let's run this. So offer first element is 5. How is 5 the first element? It was offered first, but then we also offered 10, right? How 5 is the first element? Similarly, last element is 30. Now we offered last 20 and then we offered last 30. So how are these elements being added? Right? So let's understand this example. So firstly, the output is correct. Let's understand this. So we do offer first, offer last, offer first, offer last, right? Let's continue here. Okay. Let's say let's remove this area. Okay, let's understand from an example. Okay, in the starting I have a queue, I have an array. It has 4s, 1, 2, 3, 4, 4 places. Okay, I've initialized my head equals to 0 and tail equals to 0. Okay, now I want to perform an operation where I am saying offer last and I am passing 10. Okay, so what happens in offer last? Let's go here. Offer last, where is offer last? Offer first, of peek, poll last, offer last, right? We change the value of tail, that is tail will become tail plus 1. So first we add the element, so elements of tail is equal to value. So tail is right now at 0, so at the 0th value we'll get the value 10, right? What will happen to the value of tail now? Tail is equal to tail plus 1, that is 0 plus 1, 1, mod of 4, that is elements length is still 4, so that is 1. So elements 1, 2, 3, 4, 4 elements are there, so elements dot length is equal to 4 for this example. Okay, so 10 got added here and tail got increased to tail's current value 0 plus 1 and then mod 4, so it became 1. So tail is now, which was earlier pointing to 0, tail is now changed to 1, so tail is pointing here. Okay, now again I do offer last and I pass 20. What will happen? So tail is already here. First we add the element, so 20 will come here. Then we change the value for tail, so it was initially 0, this time it is 1, so 1 plus 1, 2, mod 4 is equal to 2, so tail will change to 2, tail will come here, right? Now we say, let's say I say offer first and now I'm passing 5. Now let's see what happens in offer first, because offer first should come from the beginning. So we'll change the value of head first and then add it. But let's go to our example. Offer first, yes, we first change the value of head and then we add the value. Value of head is head minus, head is already 0, 0 minus 1 plus elements dot length we have considered 4. 0 minus 1 plus 4, that is minus 3, sorry, that is 3, mod 4, that is 3 again. So head's value will be, head is equal to 0, 0 minus 1 plus 4 and mod 4, so it is 3. So head will be pointing to 0, 1, 2, 3 here already, so value will change to 3, and we'll add the value offer 5, right? Now next time if I do, let's say I want to do rather than offer, I do pollFirst, let's say. So pollFirst. Now pollFirst comes from the head, right? So I should get 5 in return. So I will return this value 5. So I will return for return elements and wherever head is pointing, right? Head is right now currently pointing here. You see, tail is always pointing to the next one, but the head is pointing here. So for tail we always do a -1. Head is pointing here. So I'll return the value and then I will change the value of head. So head's new value will become, what do we do for pollFirst? Let's check. For pollFirst, we first return the value, then we do head plus 1. So it is at 3. 3 plus 1 is 4, mod 4, 0, right? So value of head will change again to 0. And head will again be used whenever we enter another element. Similarly, we can do pollLast, pollFirst, peak last, and other operations. I hope this is all very clear to you. Please go through this video again. I know it is a little long video, it is tedious, but please go through the video. Please understand how you can implement a custom ArrayDeque, right? And also again go through the first video on queue, so that explains what all types of queues are there, data structures are there, and which all type of implementations are available for the queue. Like the linked list implementation, we went through priority queue implementation and ArrayDeque implementation. Now I'll not go through this differences again, this comparison again. Please take a look, take a screenshot, go through them, understand them. Okay. In the end, yes, the queues are fundamental data structures that supports FIFO, unlike stacks as we have seen. And this is the end of the part 4th, which is custom implementation for Deque. So we implemented, what did we implement? Let's be sure. We implemented ArrayDeque queue, right? Custom implementation for a ArrayDeque queue. Okay, that's all from this video, everyone. For anything, please let me know in the comment section. I know the video is longer, but thank you in the end. Please like, share, and subscribe. Thank you.